All right, welcome. Today we're going to tackle a topic that's absolutely crucial for your WAEC, JAMB, and NECO exams: angles on parallel lines. And trust me, if you can master these rules, you are going to have a huge advantage. I know the feeling. You open that exam paper, the clock is ticking, and you see a diagram just packed with lines and angles. It looks like a crazy puzzle. It can feel really intimidating. But here's the thing: it's not just random maths, it's more like a code. And today, we are going to crack it. And I'm telling you, by the end of this quick explainer, you'll have a set of simple, powerful rules that will let you look at those diagrams and solve them with confidence. And a lot of the time, in just seconds. Seriously. Ready? Let's dive in. So first things first, we've got to build up your mathematical toolbox. We're starting with the three most important angle relationships you need to know. When a line, we call it a transversal, cuts across two parallel lines. First up are corresponding angles. The easiest way to think about these is that they're in the same corner at each intersection. Imagine you could just slide one of those intersections right on top of the other one. The angles that line up perfectly. Bam! Those are your corresponding angles. So what's the rule? It's simple. Corresponding angles are always equal. No exceptions. And here's a little memory trick for you. Look for an F shape in the diagram. It might be forward, backward, upside down, doesn't matter. The two angles tucked inside the corners of that F, those are corresponding angles. Next up in our toolbox, alternate interior angles. The name really gives it all away. Interior, well, that just means they are inside or in between the two parallel lines. And alternate, you guessed it, they are on opposite sides of that cutting line. And you know what? The rule here is just as easy. Alternate interior angles are always equal. Now, this is the one a lot of people remember. Just look for a Z shape. See it? The angles tucked into those sharp corners of the Z, those are your alternate interior angles. Alright, our third and final key angle type is co-interior angles. Once again, interior means they are between the parallel lines. But this time, think co for company. They are together on the same side of that transversal. Okay, pay close attention here because this one's different. Co-interior angles are not equal. Instead, they are what we call supplementary, which is just a fancy way of saying they always add up to 180 degrees. So remember, co for company, they stick together on the same side and they add up to 180. Okay, tool number 2. We're going to shift gears a little bit. We are moving from looking at angles to looking at the lengths of the lines. This is something called the intercept theorem. You might also hear it called Thales theorem. It's all about how parallel lines slice up other lines into these nice proportional pieces. The formula itself looks super simple, right? The ratio of the pieces on one line is equal to the ratio of the pieces on the other. And believe me, this isn't just some random formula for an exam. This is real world stuff. Engineers, architects, surveyors, they use this all the time to make sure things like roads and buildings have consistent slices. Okay, knowing the rules is one thing, but using them when the clock is ticking on an exam, that's the real test. So let's grab the tools we just learned and put them to work on some actual past questions from WAEC and JAMB. Here we go. Our first one, straight out of a WAEC paper. You've got two parallel lines, a line cutting through them. They tell you one interior angle is 110 degrees. So what's the measure of the alternate interior angle? Let's walk through it. First, what do we have? 110 degree angle. What do we need to find? The alternate interior one. Okay, step 2, what's the relationship? Well, they're inside the parallel lines and on opposite sides. Aha, they are alternate interior angles. Step 3, what's the rule? They are equal. So the answer has to be 110 degrees. Boom, done. Now you got to watch out though. This is a classic exam trap. It is so easy to get this mixed up with co-interior angles. Because if they were co-interior, you do 180. minus 110, and you'd get 70. And you can absolutely bet that 70 degrees will be one of the multiple choice options, just waiting to trick you. Don't do it. Alright, let's try another one. This time, it's from JAMB. A transversal cuts two parallel lines and one of the angles is 70 degrees. The question is, what is the corresponding angle? I bet you already know the answer to this one. Step 1. What are they asking for? The corresponding angle. Step 2. What's the rule for corresponding angles? They are equal. Step 3. The answer is 70 degrees. See, when you know the rules, it is that fast. And this is really key for JAMB questions. They are all about speed and accuracy. They want to know if you can recall that rule in a split second. And just like before, they are definitely going to throw that supplementary angle in there. In this case, 110 degrees, just to see if you fall for the trap. Don't do it. Alright, time to bust out our other tool. This why question is all about the intercept theorem. Imagine a triangle. You draw a line parallel to its base, and that line splits the other two sides in a ratio of 3:2. If that big base at the bottom is 20 centimeters, how long is that smaller parallel line you just drew? Okay, let's break this down. What's happening here is that you've basically created a smaller triangle on top of the big one. Now, the side of the small triangle has a ratio part of 3. But the side of the big original triangle, well, is the whole thing, right? So you have to add the parts, 3 plus 2, which gives you 5. That means the ratio of the small triangle to the big one is 3/5. From there, it's easy. Just multiply that ratio by the base length, 3/5 times 20, and that gives you 12 centimeters. So a little shortcut, a way to think about this to make it faster on the exam. All you are really doing is comparing two similar triangles, a small one nested inside a big one. The little line is just a shrunken version of the big base, and that ratio is just telling you how much is being shrunk down. Woo! We have covered a lot and fast. So before we wrap up, I want to put everything we've talked about onto one single powerful slide. Think of this as your master blueprint, your cheat sheet for acing these questions. There it is. Everything you need all in one place. Corresponding angles, they're equal. Alternate interior, also equal. Co-interior, they add up to 180. And the intercept theorem is all about those proportional ratios. Seriously, take a screenshot of this, write it down, burn it into your memory. This table is gold. So now you've got the tools. Let's do a quick pop quiz right now. If an angle is 75 degrees, what is its alternate interior angle? You know it, don't you? It's 75 degrees. See, you've totally got this. Now go get some practice in